Hi everyone. Now that we've done projectiles, horizontal projectiles, I'm going to do some projectiles at an angle. The ideas are the same, but now there is an angle. So there is a vertical component to the velocity. Initially we fired this way, so there was nothing going up or down. So it was just straight out. So the first thing I would recommend you do is that you break this initial velocity into components. So the initial velocity is VO, so it has a component in this direction, in the horizontal direction, and it has a component in the vertical direction. So that VOX is VO cosine of that angle, and VOY is VO sine of that angle. Okay, so most likely you're going to use both of them, or at least one of them. Now, in the horizontal direction, the horizontal velocity, this velocity VOX, should not change because there are no forces acting on you horizontally, assuming there is no air resistance. In the vertical direction, well, you're going to slow down, slow down, slow down. You're going to stop climbing. It doesn't mean you stop. It just means you stop climbing. So your velocity up here is not zero. Your velocity up there is all horizontal. And then you start to speed up on the way down. So at the top, the velocity is not zero. The velocity is just VOX. Okay? And the acceleration is negative 9.8 or negative 10, depending on what we decide to use. Now let's describe the motion here. I'm going to break it into an X and a Y direction. Well, in the X direction, Vx is equal to Vox equals VO cosine of theta. What do I mean by that? Well, let's say at a later time you are here. Now your velocity should be tangent to the curve at that point. Okay, and here, let's say this time here is V1, and then another time you are here. You're going tangent to this curve, so this is, let's say, V2. Well, it just means that V1x is VO cosine theta. There's no reason for it to change because this has component this way and this way. This has components right and down. These components are all equal. That's pretty much what it means. Now let's look at the y direction. Well, we say VF equals VO plus AT. This is out of the order that we did them last time. Delta Y is equal to VO plus VF over 2 times T. Delta Y is VO T plus 1/2 AT square. And VF square is VO square plus 2A delta Y. Normally I write delta X, but since we're looking at the Y direction, we're going to write delta Y. Well, this is VF Y. So basically it could be V1Y. It could be V2Y. V2 is here. Could be this one. It depends what you're looking for. So this VO, it becomes VO in the Y direction. Acceleration is G. If gravity is the only force acting on it. This is VOY, VFY. See how VOY is no longer 0 because now you're giving it something up. VOY, this becomes G. Put a Y here, put a Y here, put G here. And those are your equations. Okay? Now, a couple things you have to know. At the highest point, okay, your VFY is 0 because you stopped climbing. So you stop climbing and then you start to come down. That's that moment where you stop and you're about to start going again. A couple other things. If you are at the same, if you're going to land at the same level, the time it takes to go up to here is the same as the time it takes to go down to here. Okay? If you fire with the velocity VO here, you're going to land with the velocity VO here with the same angle that you started with. Okay. The other thing is, so we say time up equals time down. This velocity here, this is VOY. Well, if you try to figure this velocity here, okay, that's just going to be negative VOY. Okay, and those are pretty much some of the things we're gonna need. All right, so let me do a couple other things here. So let's say we fire this projectile at an angle of, let me just do a whole new drawing. So let's say we fire with 10 degrees. Okay, so it's going to do this and it's going to land there. Well, if we fire with 80 degrees, and I'm not going to do the proof for this, this angle here is 80 degrees, guess what? Going to land at the same place. If I fire with, let's say, 30 degrees, the blue one is 30 degrees, and let's do another blue one that's 60 degrees. Okay, if that's 60 degrees, well, the 30 degrees will get you, let's say, here. 60 degrees will get you to the same place. Now, the rule from here is that complementary angles have the same range. The range is the delta x, basically. That's what we call range. Now, again, the condition is that you have to be landing at the same height you fired from. Now, maximum range happens at 45 degrees. So if you fire at 45, that will get you the furthest out. It will give you the maximum range. And with some practice, you see that it's not super difficult. Okay, we just have to know a couple tricks. All right, thank you. Have a nice day.